Hello, everyone. Today we're going to talk about scientific investigation and just sort of the background of how we do science. So to get started, science you think of as biology or chemistry or physics. Science is actually all around us. So can you think of two examples in the real world where we use science? So the two examples that I think are great are that all of your cell phones have been thoroughly tested. They do tons of science on the size, the materials, the call lengths, the amount of data that is collected and used to improve our cell phones, computers, any sort of technology. There's so much science behind it. But what people don't realize is that even our food is tested, experimented on. And there's actually something called the Dorito effect, where Doritos were specifically designed to be addicting so that you can't stop. Everything from their salt content to their fat content to the crisp to the color to everything about them was investigated. So these are some more examples. Weather, and believe it or not, data is being collected on you all the time. Every time you go on social media, do a Google search, there's data, and then that data can be then used to make ads or things for you to buy. So things are science is constantly being done. So in order to do science, though, you have to start with observations. So an observation, you actually have to use your five senses. So we typically think of observations as something you see, but it can be anything else. Hearing, smelling. It has to be based on fact and is not emotional. So you don't want it to be subjective, like saying things large or small. So an example that I like to use, like if anybody watches CSI or any of those shows, if they find a dead body, just looking at that dead body is not going to help them solve that crime. Feeling the dead body, the temperature, smelling it, right? How long has that body been there? The pulse, there's so many other things besides just sight. So observations are using all five senses. So what would be two observations from the room that you're in that you could write down? So for my room, you could say the walls are white and I hear a car. I hear the engine of a car. So those are two observations. So now I'm going to test your observation skills. So here we have Taylor Swift on the left, Taylor Swift on the right, and I want to see how long it takes you to find five differences. So you can go ahead and write those down. So you can check to see if you got them. And here's Michael Phelps, the Olympian, and if you can find three differences, this one's a lot harder. All right, I think that one under his foot is definitely the hardest. So please look at this picture for 5 seconds only. 1, 2, 3, 4, 5. And quiz yourself. Do you know what the speed limit was? Were there any pedestrians or anybody walking on the road? And what color was that pickup truck? Were you able to answer all those questions? How observant are you? Okay. An inference, on the other hand, is more of an explanation of something that you observe. So it has to be based on your prior knowledge. It is not directly observed. So you usually make the observation first. So based on an observation, we can infer that. So in this picture up here, based on the New York Giants jersey and the New York hat, we can infer that the man is from New York. So there's a chance it might not be true, but based on an observation, you can come to that inference. So observations would be an example: a plant is wilted, the car stopped running. But then the inference would be the plant is wilted due to lack of water, or the car stopped running because it was out of gas. So you kind of take it to the next level. So in a lab, for example, when you record data, it should only be an observation. You can't assume why things are happening yet, so just keep that in mind. So the child has a blue block. Is that an observation or inference? The child is happy because he's playing with a car. Is that an observation or inference? And the grass is wet, so it must have rained last night. Is that an observation or inference? No one is on the beach because jellyfish are in the water. Is that an observation or inference? And the sun produces heat and light. Is that an observation or inference? Make one inference about each picture. Based on blank, we can infer blank. So I'll do one for you. Based on the fact that this girl is pulling at her face, I can infer she doesn't want to eat the broccoli. Okay, so there's the observation, and then I make that sort of assumption. I want you to look at these two coins. It's actually the front of a coin and the back of a coin. Please tell me for each statement if it's an observation or inference. There is a representation of a face on one side of the coin. The Latin word Dei means God. The coin was made by deeply religious people. 1722 is printed on one side of the coin, and the coin was made in 1722. Okay. Next is, what is the difference between qualitative and quantitative data? So qualitative means it's a quality. It is descriptive. It can't be measured. These are things like colors, textures, smells. Appearance is beauty. Believe it or not, those are observations. Okay. People typically think of quantitative things, numbers, data, length, height, area, weight, these things as data, but they are both data. So qualitative data and quantitative data. You just look at the root word to see that one is a quantity and one is a quality. So here is the biggest flower on Earth. It's called the Rafflesia arnoldi, and it's called the corpse flower because it actually smells like rotting meat. It's pretty cool. It's about 3 feet wide, and it weighs about 20 pounds. What else about it? But unfortunately, it only blooms for 1 week out of the year, and it can only be found in Southeast Asia because that's where the proper climate is for them to bloom. So it's a pretty interesting flower. So based on some of that information, do you think you could write down some qualitative information and some quantitative information about the flower? Okay, some qualitative things are that it's red, it has spots, it smells like rotting meat, and it has sort of a fleshy texture. Quantitative would be that it's 1 meter in diameter, so about 3 feet across, it's 20 pounds, and the flowers only last for, about a week, 5 to 7 days. Okay, so those are number things about it. So here's actually me in Thailand when I studied abroad in college, and you can see sort of this Thai writing back here. We went to a forest to go see them, but it was not the week they were blooming, so they put up big fake flowers for everybody to take pictures with. So I missed it. But it turns out the Bronx Zoo a couple years ago had an exhibit where they had this big glass box, so I couldn't smell it, but they created the proper environment for this flower to bloom. So at least I got to go see it, even though I didn't get to smell the rotting meat aspect. So this is just a question I have. Does anybody know why this flower would smell like rotting meat? Any ideas? Usually kids say things like for protection, to keep animals away, but in reality it's actually so that bees will come pollinate it. So the way a flower that we think of typically smells good to attract bees, right? So that they take the pollen from one flower to another flower. This flower has a similar mechanism in that it smells bad so that bees will come land on it that flies will land on it thinking it's a dead body, a dead animal, and then they realize it's not, so they go to another flower. And in that process, they have now transferred the pollen from one flower to another, and that's how it makes baby flowers. So that's a really cool evolutionary trait that this flower has evolved in order to reproduce. So to end here, if this picture here, if you could write 4 observations, of those observations, I would like 2 of them to be quantitative and 2 of them to be qualitative. And I'd also like you to write 2 inferences. So just keep in mind that in the real world, when people do experiments, they do both use quantitative data and qualitative data. So if you, for example, are doing designing a medicine for depression or something like that, people might have to actually describe the quality of their life, how they're feeling. And so that's not necessarily a number, right? But for other medicine, blood pressure medicine, things like that, you definitely would want a number, quantitative. But even how I was talking about those Doritos, how they design them, they test them on people and they have people describe flavor and crunch and colors, things like that. So those things would be qualities that are observations, not necessary quantities. But then they also would need quantitative data about the Doritos. How many grams of sugar, how many grams of fat, how many milligrams of salt. So keep in mind that this is used in the real world. We're just using, sample pictures just to practice the skill a little. All right, so that's our PowerPoint or our information about how to collect data for investigations. Okay, and next week we'll get into some more investigations. All right, bye.